Hello everyone, here I go again, Carlo Breis at your service. I am here again to share with you some information about microeconomics. Let us have first let us have a recap. As I remember, the last time I did a video, I have defined the words economics and microeconomics. I also defined some basic words that are related to these two. Now, I have new topic to discuss with you. And this topic is what we call linear programming. So to start, again, as usual, let us first define the word linear programming. Linear programming is a method used to achieve the best outcome such as maximum profits, or lowest cost. In a mathematical model whose requirements are represented by linear relationships where the variables are subject to constraints. This is the definition of linear programming. So now, to make it easier for all of us, I will just give you a problem. No, I mean a word problem to solve, because if I give you a problem, I'm sure you'll hate me. No, I'm just kidding. So I'm going to give you a word problem to make this easier for us. So this will be a word problem solving type of discussion. There are steps to be followed to be able to solve the linear programming. And those steps must be observed. Step 1 is to analyze. Of course, that is the first step. How can we do anything without the analysis of the problem? So, the first step is to read the problem carefully and analyze what are the important things that must be considered. Then step 2 is identify the objective function. This is the second step. But how can we identify objective function without reading the problem first? Of course, we must read the problem first. So I'm going to read it for you guys. A company is involved in the production of two items, X and Y. The resources needed to produce X and Y are twofold, namely machine time for automatic processing and craftsman time for hand finishing. The table below gives the number of minutes required for each item. So later on, I will show you the table for the machine time and the craftsman time. The company has 40 hours of machine time available in the next working week, but only 35 hours for the craftsman time. So these two are the limits. Machine time is costed at 10 per hour work, and craftsman time is costed $2 per hour work. Both machine and craftsman idle time incur no costs. The revenue received for every item produced is $20 for the product X and $30 for product Y. The company has specific contract to produce 10 items of X per week for a particular customer. Let X be the number of items produced of the first item, and let Y be the second item, each unit of the second items produced. So, to identify the objective function, go back to the problem and analyze what is the objective of this. In this problem, the objective is to maximize profit. We may obtain the objective in the constraint function from the problem. Of course, these two will be coming from this problem. From this statement, which is the revenue received for each item produced is $20 for X and $30 for Y. Therefore, our objective is to maximize profit. But don't forget, there is a cost. So we need to consider it in maximizing our profit. The cost is, going back, machine time is costed at 10 per hour work and craftsman time is costed $2 per hour work. So these two are the things that must be considered to be able to identify our objective function. Therefore, our objective function is $20x is $30y So, 20x plus 30y minus 10 times machine time work minus 2 times craftsman time work. The 20 here is the revenue earned for selling each unit of product X, and $30 is the revenue earned for each unit of Y sold, minus machine time work. 10 times machine time work, because 10 is the cost of producing each product of X, times the machine time work, then 2 is the cost of each unit produced of product Y. Now, the second thing to do is to identify the constraints. In this problem, we have 3 constraints: the machine time constraint, the craftsman time constraint, and the constraint about the contract. So let us go back to the problem and read it again to be able to identify these constraints. Here are those statements that we must consider. The resources need to produce X and Y are twofold, namely machine time for automatic processing and craftsman time for hand fishing. The table below gives the number of minutes required for each item. So again, I'm going to draw a table later. The company has 40 hours of machine time available in next working work, but only 30 hours of craftsman time. And the last constraint is that the company has specific contract to produce 10 items of X per week for a particular customer. Now, I'm going to show you the table. Remember the objective function, guys. Here's the table. Remember, This time given is in the unit of minutes. Therefore, the constraints are oh, I forgot. There is a limit of limit on the available time of the machine and the craftsman. And those are, let me erase it for you. Available time is 40 for the machine and 35 for the craftsman. So the objective functions are 40, and constraint function rather, and then 20x plus 29y is equal to 35 times 60. Less than or equal. We have here a inequality sign. So notice this constraint function. We have here in an inequality sign. This constraint function is the machine time. And the other is the craftsman time. This constraint function means that the time of production of each unit must not exceed the limit on the available time for both machine time and craftsman time. Therefore, 13 minutes, which is the time required to produce 1 unit of product X, plus 19 minutes, which is the required time to produce 1 unit of product Y, must be less than or equal 40 hours. Then the second one is 20 minutes. We're talking about on the machine time on the first constraint. But in the second constraint, the craftsman time, the 20 minutes, which is the required time to produce each unit of products X, plus 29 minutes, which is the required time to produce 1 unit of product Y, must be less than or equal to 35 hours. Now, observe that there is a number 60 on the both constraint. Why did I do that? I did it because this 40 and 35 is in the units of hours, while this side, the numbers in there is in the unit of minutes. So it's either to convert the 40 and 35 into minutes or convert the numbers 13, 19, 20, 29 into hours. So I've decided just to convert these two for the purpose of convenience. So we must multiply 60 because in each hour, there is a 60 minutes for each hour. So 40 hour is equal to 40 times is equal to 2,400 minutes. minutes. The other one is 35 times 60, 2,100 minutes. Oops! There is another constraint, which is the contract. The problem states that the company has specific contract to produce 10 items of X per week for a particular customer. Therefore, the constraint function is x must be greater than is equal or equal to 10. This constraint function means that x must be greater than or equal 10 to be able to satisfy the need of the particular customer. Now that we have identified what are the objective function and the constraint function, the third step to do is to substitute the value of 0 to every variable that we may see in each constraint function. So, let us now do it. But let me rewrite the objective and the constraint function first. The objective function is 20x plus 20y minus 10 times 30x minus 60. Observe that I have already substituted the values here. 10 is the cost to produce each unit of 10 is the cost to produce each unit of products X and Y using the machine, and $2 for the craftsman. So we may able to get the cost by multiplying 10, which is the cost per unit using machine, times the times the required time to produce X times the number of units produced units of X produced plus the required time to produce product Y times the product Y produced over 60. Notice the number 60 here. Again, because this 10 is talking about the cost per hour. Cost of producing one unit using the machine per hour. So, the third numbers 13 and 19 is in the units of minutes. So, we are going to convert it into hour. That's why we divide it into number 60. The same here with 2 times 20x plus 29y divided by 60. So, now I'm going to rewrite the constraint functions. Constraint functions are 13x plus 19y equals 2,400. We obtained 2,400 by multiplying 40 hours times 60. Because, again, in each hour, there is a 60 minutes. Second constraint is, I'm going to solve it by substituting the value of 0 in each variable, one by one. Remember, you must not substitute 0 in all because it is nonsense. You will just get the number of 0. So, we're going to substitute it one by one. Let us do it in the first equation first, which is 13x plus 19y equals 2,400. Let x be the 0, so 19y is equal to 2,400. Divide both sides by 19. So y is equal to, let us calculate it, because I don't have a calculator mind. By 19 is equal to 126.315. Now, we can't write a decimal because we are talking about units, number of units produced. So we need to round it off to the nearest whole number, which is 126. So second, substitute the value of 0 to the y. Let y be the 0. Therefore, 13x is equal to 2,400. Divide both sides by 13. X is equal to 184.615. Again, we should round it off to the nearest whole number. So the answer is 185. So the first intercepts are no, I'm sorry. The first combination of intercepts is 0 and 126. Then the second is 185 and 0. The first combination of intercept means that produce nothing of product X and produce 126 units of product Y. The second combination of intercept means that produce 185 units of product X but produce nothing of product Y. Take note of that, guys. First is where I'm going to write it. First is 0, 1, 2, 6. Second is 1, 2, 5, 0. So let us now use another constraint function. That is 20x plus 29y equals 2,100. Again, let x be the 0. Therefore, 29y is equal to 2,100. Divide both sides by 29. Y equals 72.41. Rounding. Again, we must round it off to the nearest whole number. So the answer is 72. Second thing to do is let y be the 0. Therefore, 20x equals 2,100. Divide both sides by 20. So we will obtain an answer of 2,100 divided by 20 is 105. So the first combination of intercepts are 0, 72, and the second combination of intercepts are 105 and 0. Now that we already substitute the values of 0 to all variables that we can see, the fourth step to do is graph it. Make a graph of it. We just need to plot these points to the graph. So let us make a graph. Let us make a graph in a scale of 20 by 20 because as you can see, we have a small whiteboard. 120, 60, 60, 200. The next thing to do is plot these points. First one is 126 in the y-intercept. So it's here. Then 185 in the x-intercept. So it's here. So we need to connect the two dots. And that equation is our first constraint function, which is 13x plus 19y equals 2,400. Because we obtain this combination of intercepts by substituting the value of 0 to this constraint function. Now the second one is the 20x plus 29y plus equals 2,100. So we have here the combinations 0, 72 in the y-intercept and the 105 in the x-intercept. So it's here. Again, connect the dots. The last constraint that we must consider is x equals 10. 10 is here. Assuming 10 is here because we start in the scale of 10, so the dot must be before the 20. 10 is here, and we must draw a line upward to observe an intersection. Now, remember this, guys. Always remember this. The values that will maximize our objective function is the closest to the point of origin. The point of intersection, which is nearest to the point of origin, are the values that will maximize the objective function. And those values are between 60 and 80. So let's assume that it is like 65 for the y-intercept, and between 100 and 120. So let's assume that it is 100 or 100 plus. So those values that we assume are 100 or 65. It is not approximate, guys, because oh no, I am mistaken myself. I'm sorry. Sorry for my fault. The values are 60 plus for x, 60 plus for x, and 20 or 10 for 60 for y rather, and 10 for x. So we have 10 and 60. This is just an estimate. So to know the values exactly or accurately, we must we must obtain the values by solving these constraint functions. And we have different methods. We have two methods to solve these functions. First is the substitution method. Again, the constraint or the values that will maximize the objective function is the point of intersection that is closest to the origin. And those point of intersection are 20, and the x is equal to 10. These are the constraints that intersects closest to the point of origin. So, These are the two that we are going to solve. Now, the first method is the substitution method. Let us now do it. Let us substitute, because x is equal to 10, let us substitute the value of 10 to the x. So 20 times 10 plus 29y equals 2,100. So 200 plus 29y equals 2,100. Therefore, 29y is equal to 2,100 minus 200. 29y equals 1,900. So divide both sides by 29. We will obtain the answer of 1,900 divided by 29 equals 65.52. Again, round it up to the nearest whole number. So our answer is 65 or 66. So the precise value of y is 66. The value that will maximize our objective function, the y value is 66. So the for the sake of discussion, I will also use the other method, which is the method of subtracting the second function from the first constraint function. Now, let's try it. Second method is x equals 10. Now, to be able to subtract these two, we must think of a number that we will multiply to x to be able to equate this x to the x of the first constraint function. And that number is number 20. So, to rewrite it, we have 20x plus 29y equals to 1 minus 20x, because 20 times x, we will get the answer of 20 is equal to 20 times 10 is equal to 200. Now, cancel because it is a subtraction. Bring down 29. Bring down 29y. 2,100 minus 200 is 1,900. Therefore, 29y equals 1,900. Again, divide both sides by 29. And we have the same answer. And that is 66 again. Let's check it again. Yes, 66. Now, observe that we obtain the same answer from both method of solving it. So I suggest that you do not bother of thinking what method to use, because you can use either of the two methods. To be able to get the value of x, we must substitute the value of y that we have obtained in solving the two linear functions, or constraint functions rather. This function is 20x plus 29y is equal to 2,100. Why not 13x plus 19y is equal to 2,500? Because we didn't use this constraint function to solve the value of y. We used this and x equals 10 instead. Because as we remember, going back to our graph, the constraint functions that made the point of intersection closest to the point of origin are these constraint functions, which is 20x plus 29y equals 2,100, and the x equals 10. So now, let's do it. Remember that the value of y is 66. So 20x plus 29 times 66 equals 2,100. 20x plus, let us calculate the value of 29 times 66. That's 1,914 equals 2,100. 20x equals 2,100 less 1,914. And that's 2,000. That's 186. Divide both sides by 20. And we got the answer of, that's 90.3, I guess. Let's calculate it if I'm right. Yes. Oh, I mean 9.3. Why 90.3? 90.3. Sorry. My mistake. So the value of x is equal to 9.3. As you may notice, we assume a values of estimate according to the graph, and we had the values of, as I remember, the values of 10 for the x and 65. Remember, that was just an estimate. And notice that it is much close, so our answer is correct. Compared to our answer to the graph, which is 10, and the value of y, which is 66, is close to what we had on the graph, which is 65. These two are the estimates, and these are the exact answer, 9 and 66. So, the values that will maximize our objective function are the values 9 for the variable x and 66 for the variable y. And this means that produce 9 units for the product x and produce 66 units for the product y. Yes, correct. Produce 9 units of the product x and produce 66 units of product y.